everyone, I'm Shadaj, and today I'm going to be talking about Slinky. So before we dive into the details, a quick TLDR. Slinky is a way to use React from your Scala applications, and now we can't see either. Okay. Okay, sure. Okay, so Slinky lets you use React from your Scala applications. But before we go into what Slinky is, let's talk about why Slinky. So the way we write web applications has fundamentally changed in the past few years. So the traditional model of a web application is you have your persistence layer, you have your server, and that server is emitting your HTML. And that would probably be a Scala application. You might be using Play Framework for that, using something like Twirl to generate your HTML. That all gets sent to your browser, and there you might have a little bit of JavaScript to make the app more interactive for your users. But usually the majority of your code was this back-end Scala code, and then you had a little bit of front-end JavaScript. But in recent years, it's kind of shifted where your back-end, instead of serving HTML, is now just serving data. And your client side is what's generating the HTML. So now you'll have your JavaScript code, which is generating HTML. That makes it possible to offer much more rich experiences, because based on how the user is interacting with the page, you don't have to wait for the server to come up with responses. You can immediately provide feedback. So how can we implement this new web? Now, one of the first solutions to this was jQuery. So with jQuery, you get a nice API. You can interact with your website. You can modify DOM properties. You can animate nodes. You can get data from your servers. So this is kind of your usual flow. You start by loading some data from your server. You check what's being currently rendered, because you need to update it to show the latest results based on your data. You apply the adjustments. And then some later point, you'll read some user input. Maybe they fill out a form, and you send that data to the server. And then you repeat this cycle. The server sends you new data, and you start all over again. But it ends up looking something more like this, where as soon as you try to apply the adjustments, you forget to delete some HTML nodes that were added by another part of your code. So maybe some guy created a pop-up. You forget that that guy created a pop-up. So now you have a pop-up there, but you're trying to show content on the main page. So you end up with that issue. And then when you read user input and send it to the server, oftentimes you'll just leave the user staring at a spinner, and your web app won't be interactive because you're just waiting for that response to come back before you can start the cycle again. So this isn't a great way to implement the new web. It worked, and it was a lot better than what we had before with everything happening on the server side, but it's still not great. So the problem we're trying to solve here is we have two sources of input. We have this data coming from the server, and we have user input as the user's interacting with the web page. And we want to combine these two sources of information and turn them into views. And so one recent solution that was created to solve this issue is React.js. So just a quick show of hands, how many of you guys have used React before? OK, cool. So a good number of you guys. So React is a web framework created by Facebook to simplify this process of taking data and user input and turning it into views. So React is used by lots of companies. It's used by Facebook for all of their apps. It's used by companies like Twitter, by Uber, by Microsoft. So it's there everywhere, and it really makes this process a lot simpler. How? It takes the structure that we just talked about, this problem that we're trying to solve, and that is how you write your code. So your React application structurally looks like this. You have a function from your data and user input, and you turn it into views. Now, you don't call it data and user input. In React, you call it props and state. So props is something you're receiving from higher levels of your application. It might be something like configuration. It might be something like data from your server. And then you have state, which is something local to individual parts of your application. And that's usually your user input, and you're turning it into a view. So let's take a look. So this is JavaScript. This is how you would write your simple hello world component. So you create a class. It extends to React.component. And then the core part of a React component, which is a subset of your application, is going to be this render. And render is kind of defining what you put out onto the page. So here we're creating a component that will take some input, which is the name of the person we're saying hello to, and it's going to be outputting hello to that person on the screen. So we're constructing a div. Here you can see in JavaScript you can use regular HTML syntax to render these nodes. And then they have this templating syntax to say, we're going to take this value from our props. So any attributes you pass into this component are automatically going to be filled into the props. So here we're taking the name value from the props, templating that in. And then if we want to render it at the bottom, we can just do hello message with the name is Taylor. And that name is what's going to be fed into the prompts. So this is a simple application where we're just dealing with prompts, but more often, you'll also have state. So this is an example of creating an application with some state. So here, what we're doing is creating an application where we take some user input and we just mirror it back to the user. So what we want to do is we want to keep track of what the user has typed into a text box. So we have this input. We're saying on change. We're going to handle the input. So what we're doing here is just saying, OK, if we receive an event that the user has typed something into the text box, we want to update our local state of what has the user typed in. And having this flow of separating, gathering your state from using your state is what makes React so powerful. So we have one part of your application that's saying update the state. And then in our render, we can just use the state. So if the user types something in, it'll update your state, and then it'll go back to this render. And that's how you can keep your views up to date. So in this case, you would have a text box and a p tag, which is just containing this user input is what the user has typed in. So hopefully this gives you a quick idea of what React is like and what writing components is with React. So you might be wondering, OK, we talked about JavaScript, web apps. What does Scala have to do with any of this? So Scala.js is a tool that takes your Scala code and compiles it into JavaScript. And that's what's going to make Scala applicable to all of this. So let's say you have an object called Scala Fiddle. You can actually try Scala Fiddle online and see the results for yourself of how Scala.js turns your Scala code into JavaScript. But it'll look something like this. So it'll generate a JavaScript object with some init method. And the important thing here is Scala.js outputs regular JavaScript. There's nothing special needed. You don't need to run it in a special browser. It's not. You don't need any special frameworks around Scala.js. It's just pure, plain JavaScript, including the ability to interact with JavaScript libraries and build tools. And that's what's going to allow us to use React from Scala.js. But also, why not just use JavaScript? I mean, after all, React.js was developed as a JavaScript framework, not a Scala.js framework. So Scala gives you a lot of capabilities. First of all, it gives you strong static typing. I think this is something that we all love about Scala. And the really great part about Scala is you can get all of this without losing conciseness. Now, that's something people often fear. JavaScript developers, if you're moving to a statically typed language, it can often add a lot of verbosity where you have to specify your types everywhere. But with Scala and type inference and more advanced language features, we're able to ensure that your code is safe before you run it without making your code super huge with all these types everywhere. The next important thing is code reusability between your server and client. So how many of you guys use Scala to write server-side applications? OK, so pretty much everybody. So that's what Scala was primarily intended for, is writing backend applications. And now with Scala.js, you can actually bring the exact same code you run on your server into your client. Now, this has a lot of advantages. First of all, if you have models, that means you can share the exact same code. Now, one issue that a lot of developers face is you make some changes to your models on your backend. Now you have to notify all your clients and developers that, hey, the shape of my data has changed. Make sure to update your app to it. You might run into problems if you deploy your backend before the client-side devs update it. With Scala.js, you can use the exact same code to make sure that your client is working with the exact same models that your server is emitting. And in addition, if you're developing things like maybe some algorithms to process data, this allows you to migrate the potentially computationally intensive task of running the algorithm on your server to the client. So then you can save computational resources. Next, you get advanced language features. Now, macros can be very scary. But when used correctly, and we'll talk a little bit more about this later today, they can be extremely powerful and can eliminate a lot of boilerplate. And lastly, but most importantly, Scala has an ecosystem of lots of professional libraries and tools. So from Scala Test to things like Diode and Scala RX, there's a whole wide variety of Scala libraries out there for almost anything you can think of. And majority of these libraries are now compatible with Scala.js. So as soon as you switch to Scala.js, you have access to this entire range of this ecosystem. So one way to use Scala.js with React is Slinky. And Slinky is a library I started working on about 1.5 years ago. And now it's grown into an extremely powerful framework that goes beyond just offering an interface to React, but making your whole developer experience when using React from Scala.js fantastic. So what does Slinky let you do? And there are kind of 4 main parts to Slinky, and we'll go over each of these in detail. First of all, most importantly, it lets you use React from your Scala.js code. So anything you can do in React, you can do with Slinky. You can use it along with Scala libraries and tools. So Slinky has great interop with existing Scala libraries and tooling like SBT and other plugins. But in addition to using Scala libraries and tools, you can also use JavaScript libraries and tools. And this is really important if you're developing client-side applications. Because when you're working with React, there are not that many libraries for React components in Scala.js. But there are a lot of libraries for React written in JavaScript. And so Slinky allows you to use these existing modules in JavaScript land and bring them into your Scala.js code. And lastly, one of the main points of Slinky is to have a developer experience that's as great as JavaScript. So if you've written apps with JavaScript for the client side, you'll know it's a really fantastic experience. With things like hot loading, you can make a change, save it, and by the time you're back in your browser, you'll see the results. And so Slinky tries to bring over a lot of the great features that you have when developing with plain JavaScript and bring them over to Scala.js. So let's write some code. So I'm going to do this completely from scratch, so hopefully the internet will work with me. So the easiest way to get started with a Slinky app is to use a template. So you can do SBT new create, and this is giving away a later part of my presentation, create React Scala app. So you hit enter. The internet will hopefully work with me. SBT will take a little bit of time to boot up. OK. So the name we can do like Scala Days Demo, Hello World. OK, so now we have a Slinky app. So if I open this up in IntelliJ, and hopefully this will happen fast enough, and I'm going to launch SBT in the background so that we can get started with building this. So, OK, let's import this. OK, I'm probably just going to open this in VS Code in the meantime so we can start going through the code. And boom. OK, so this is kind of the base layout of our application. Slinky uses SBT, so everything you know about building applications with Scala with SBT, you can bring over to Slinky. So let's take a look at our main code. So we have our main launcher. So here we're importing some CSS. And then we're going to be rendering some content. So here, we're doing stuff like initializing hot reloadings, and we're going to see this in a bit as soon as IntelliJ actually boots up. And then at the bottom, we're using React DOM.render. So for those of you guys who have written React apps with JavaScript, the syntax for rendering components in Slinky is very similar, but instead of using HTML syntax, because XML literals are going away in future versions of Scala, Slinky instead uses this kind of apply method where you pass in all of the parameters just as if you're calling that component. So let's see if IntelliJ. OK, cool. So now we're in IntelliJ. And now one of the important things with Slinky is Slinky actually has full compatibility with all the IDEs you use. So if you're using IntelliJ, you'll get full code completion. And actually, in a future release, Slinky is going to be supporting the new library injectors capability of IntelliJ. So you'll get even more advanced code completion with Slinky projects. So if we want to look at the main code, so this is our app.scala. So here, this is kind of the core component that we're writing. So we're importing some CSS. We're importing an SVG. If you guys have looked at the original kind of create React app, this mirrors that. So in SBT, if I want to launch this, I can do fast opt.js, start Webpack dev server. So it will compile our code. It will update our NPM dependencies. So Slinky works with NPM dependencies, so you can import everything from there. It's going to install stuff, so that's going to take a little bit of time. So let's switch back to IntelliJ while that's running. So here we have a component. So when we're writing a component in Slinky, it looks very similar to what you would do in JavaScript. You have your @React class app. Here, our component is stateless, so Slinky can actually fill in a lot of the code for us if we tell it that it's stateless, so then we don't have to define any state or initial state or anything. And then we have our render. So our render, again, looks very similar to what you would write in JavaScript, except instead of using HTML style syntax, you have this apply syntax. So if you guys have used things like Scala tags, this will be very familiar to you. So here we can specify that the class name is app, and that's going to tie into our CSS. And then we can put some strings out. So this is kind of your Hello World Slinky app. So it's compiled successfully, so we can open this up in our web browser. And we can see this is our first application with Slinky. So now we can start editing it. Let's say we want to add some state to our component. So what I'm going to do here is let's just create an application that reads some input from the user, displays it, and maybe we can have some validation to, say, make the text red if the user types in any integers. So let's take a component. Our state is going to be a string because we're going to store whatever the user has typed in so far. Now, if we hover over this, we'll say, oh, we need to implement initial state. So as soon as you define an initial state type, you also have to define what that starts out to be. So this is going to be an empty string. OK, so now inside here, we can get started by getting rid of this. And let's replace it with an input. So input is your regular text input. Now on change, so that's whenever we get the user types in any content, we want to keep our state up to date. So we're going to take our event and do something with it. I need to wrap this in parentheses. OK. So now that we have our event, this is just a regular HTML event. We can take the target. We can cast it. Now, this casting is not super great. It's going to be improved in a future version of Slinky as soon as the IntelliJ guys fix a bug with their error highlighting. So we can, for now, just cast it to an HTML input event, and then we can take the value. So this just gives us a string. So this gives us the latest state. And now to update our state, we can just call setState with this value. OK, so in the meantime, we can start FastUp.js in watch mode. So this will allow us to see hot loading in action. So if we go back here, you'll see that our app instantly changed. So without any reloads, we're up to date with our app. We can even use the React Dev Tools. And we'll go into kind of all of this as part of that developer experience. But you can see here we can hover over the app. We can take a look. OK, so we can see our state is __ as we type in. We can see that our state is getting updated with that. So we're on the right track. Now, what we want to do is we want to populate this input with the text that the user has typed in so far. And then we also want to colorize it based on this validation scheme. So what we're going to do is on inputs, just like you can do in HTML, you can set a value. So we're going to keep our value up to date by using our state. So our value is going to be our state. And then we're going to set color. So colors are CSS. So you can set that using the style attribute. So in React, styles are set as a just plain JavaScript object. So you can use js.dynamic.literal to create a JavaScript object. And then we can set the color is going to be if our state.is .for all. So if every single character of the state is a letter, we're going to say it's green. Otherwise, it's going to be red. So if all the characters are letters, we're good. If the user types in a number, it's bad. So OK, compiled. So now if we type in, let's zoom in. So if we type in just plain old letters, it's all green. The moment we type in a number, it's red. And that's writing apps with Slinky. So that's your kind of super quick overview of how you can write apps with Slinky. And now you might be wondering, OK, that's great. Everything works. But like, how we rewrote some code. How did it actually end up getting turned into this application that's keeping track of our state, getting input from the user? So first, JSX. When we looked at those examples of writing applications with JavaScript, you saw that we could use this HTML syntax. Now, this is not something that's part of regular JavaScript. So the way it actually works is when you write your code using that syntax, there's actually a compiler in between called Babel. And that is what's going to convert this syntax of having these HTML tags inside your code and convert it into just regular vanilla JavaScript. So if you write something like this in a JavaScript, it gets turned into something like this. And now this is a lot more familiar to us. It's just a regular method call. And this is something that we can call into from Scala.js code. So the way we call into that is we define a static facade over this. So this is one of the great things about Scala.js is even if you're working with external JavaScript libraries, you can still call into them using static types. So here we're using one of kind of the newer features of Scala, which is the ability to import from Node modules. So we're importing from the React module. And then we're defining that you can create an element. You can use a string or an object. When it's an object, that means you're creating a component. You can pass in properties and the children. And it gives you a React element at the end. So this works. This is great. We can create HTML nodes. But what about components? Now, components are much more kind of complicated. You are actually creating a class that extends an external JavaScript type, and then you're implementing methods for that type. How do you generate something like this in Scala.js? Now, the really great thing is Scala.js defined. Scala.js defined is a fairly recent addition to Scala.js. And what this allows us to do is annotate Scala classes with this at Scala.js defined. And then at compile time, Scala.js will actually convert this into a regular JavaScript class. So we can do something like this, where we define a component that is just a regular kind of Scala.js native type. So we're saying that we have a component. This is part of the React library. It takes JSprops as a constructor argument. And so if you want to extend this but emit a JavaScript class instead of a Scala.js version of a class, we can just use this at Scala.js defined annotation to create this class and then extend. And that gets turned into this when you actually compile it. It won't look exactly like this because this is using ES6 syntax. Scala outputs kind of more olderish JavaScript. But you get what's equivalent to writing this in your React application. So that's solved. Now we can write components. Now another thing that when we were writing our code, you might have noticed this at React at the beginning. And so the code kind of makes sense. So when you're looking at it, OK, I'm defining my props. I'm passing in my name, which was defined in my props type. But if you kind of look a little carefully, a lot of the things that are going on in this example don't make sense. There's no way this code should be compiling. Where is hello message.apply? Because we're calling hello message with parameters. Where is the companion object? Where is the apply method? Where is the React component class? Because if we're creating an instance of a React component, there needs to be a React component class somewhere. So kind of the answer to that is the at React annotation is actually a macro annotation. So this kind of goes back to this idea of macros being super powerful when used carefully. So if you write something like this with at React class, it gets transformed at compile time to something like this, where you have this wrapper, you define your props in there, and then inside that you have your actual Scala.js defined React component class. And then it also generates apply methods for you to use. Now, one important thing to note is even though this at React annotation is available, it's not required. And this code that it generates isn't just kind of what it means. This is an actual code that you can just write instead. So if you want to, for your application to maybe reduce compile times, or your developers are scared about using a lot of macros, you can just choose to use this wrapper style. And that's actually how Slinky started out with, is just having this style. This is just pure Scala code, no macros involved now. So that's it for kind of the basics of how Slinky works. Now, one of the core parts about Slinky is working with the ecosystem, because there are a lot of tools out there. And it's really important for us as developers to not only kind of write the code for our product, but also build on top of code that other people have worked so that our applications are as rich as possible. So the main way that we work with external code is through external components. So there are a lot of React components out there, and we want to use them from our Scala.js code. Now, with Slinky, that's super straightforward. So for example, let's say we wanted to use React Router. So React Router is a super popular package for React that allows you to implement routing capabilities. So basically, if I'm on a specific path, the user has navigated to a path, render this component. And it allows you to link between things. It's super powerful. So we can import it. So this is our regular Scala.js importing from a node module. We can say, oh, we have this route. This is a React component. And if we want to interface with this, then all we have to do is extend external component, define a props type. So the idea here is you're using a very similar API to what you use when you're writing components in Scala. You, again, just have to define the props type so that you have a statically typed interface. And then you define what component to be actually creating an instance of. So in this case, we're saying it takes a path, it takes a component. Now this is an interesting thing. The component type here is actually supposed to be a reference to a React component class. So not an instance of a component, but a reference to it that React Router can create an instance of itself. And Slinky actually supports this method of passing in components. So it'll automatically take a reference to kind of a Slinky component wrapper and take that and convert it into a reference to the component class. And you can also define things like default parameters, and then those will just be passed in automatically. So this is all great, but we can't just pass a Scala object to a JavaScript component because Scala.js has its own encoding for Scala objects that isn't compatible with what JavaScript components are going to be expecting. So in this case, if we just took an instance of props and passed it into this React component, you'll get lots of errors because it's nothing like what the shape it expects. So if we took something like this, it would look something like this. And this is kind of optimized Scala.js code. You get these properties. They're optimized because Scala.js is reducing your code. But this isn't great for working with external components because this is nothing like what they expect. They're expecting a path and a component. So the solution that Slinky has for this is writers. So writers are a type class. Basically, what they let you do is you can implicitly grab an instance of a writer, and writers handle the process of taking Scala types and converting them into JavaScript types. So now if we get this writer of props, and this is automatically derived using John Purdy's library Magnolia. So that handles generating this writer. And then you just call it .write with a Scala object, and you generate this nice JavaScript object. And then you can just pass that in to the component. So now we've solved the problem of working with external components. External components are extremely powerful because they let you, there's so many great libraries out there for JavaScript, they just allow you to eliminate large portions of your code. So for example, instead of writing your own router, you can just use React Router, which is a fantastic library, handles things like server-side rendering, everything works great. If you want to have a data layer, let's say you're looking at using GraphQL. Slinky works with React Apollo, so you can use the Apollo GraphQL client, and you can make GraphQL queries and tie them into your React components through Slinky code. If you want to style your components, maybe using a common set of styles that your organization has created, you can just use styled components. So styled components is another React library. It just works with Slinky. If you want to render 3D objects that are being animated on your page at 60 frames per second, maybe you're creating some super fancy app, then you can use React 3 Render, which is a way to render 3D components from your React application. And that just works with Slinky. So really, this just allows you to tap into this whole world of libraries that people have already been developing for years for React from your Scala.js code. Now, build tools. So build tools, you have SBT. But on the JavaScript side, you also have Webpack. And thankfully, thanks to Jorge's tool, Scala.js Bundler, this is very easily solved. You can define all of your settings for your Webpack configuration in your build.sbt, and then Scala.js Bundler handles the entire process of generating config for your Webpack, running it, and you're done. So I'm not going to go into too many details of this because it just works, and it's fantastic. Now, another cool thing that Slinky supports is reverse interop. And this is especially important if you're introducing Scala.js to an organization that already has an application using plain JavaScript. So if you already have a bunch of client-side devs who are using React and JavaScript, but you want to introduce Scala.js to them, Slinky supports the ability for JavaScript code to call into Scala.js components. So let's take a look at it. So I have this demo. It's open source. And so if I open this up, I can open this up in VS Code. And then in the meantime, I'll launch a server. So wow, this is really big. OK, so let's take a look at this code. So this is what your client-side dev would be writing. So let's say we wrote a component app. Let's take a look at the Scala.js code first, actually. So we have our component app. This is the same Hello World app that we were looking at in the beginning, except now we change the props to take JSX message, just to show that we're actually passing in data from JavaScript into Scala.js code. So here we're going to be rendering some message based on what the JSX code says. And then all you have to do to export this to be accessible in JavaScript code is you define this JS export, and you say that this app is my app. So that you just have to do this for every component that you want to make available to your JavaScript developers. Now, from the perspective of a JavaScript developer, so and this is really important if you want to kind of incrementally adopt Slinky, you want the experience using Slinky from JavaScript to be no different than just using regular React components. You don't want to force your developers to learn anything new about, oh, I have to come up with a special shape of my data for Scala.js. And here, if we just do exactly, write our code exactly the way you would do it for if you're using any regular JavaScript library, you import app from Scala.js, and then you can just render your app. And everything just works. So if I open up this, I can launch my Webpack dev server. So this is using Scala.js bundler. So it is going to be bundling things. OK, so it launched. And oh, I'm already running a Webpack dev server. So let me stop this one. And let me launch this one. For real this time. OK, cool. So now if I reload my page, the message passed in from JSX is hello. And that's what we passed in from our JSX code right here. So if you're looking at introducing Scala.js to your clients and developers, this is a great way for them to get started, maybe one component at a time. All right, that is reverse interrupt. Now, beyond the web. So when we introduced this idea of the structure of a React application, remember that it was props and states to a view, not props and states to HTML. And this is something that's been, this kind of concept of a view can mean more than HTML has been used a lot recently with tools like React Native and React VR. So let's take a look at a couple examples. So Slinky can actually be used to create native applications. So I'm going to go to Scala.days, and we're going to create, hopefully everything will work. There's going to be a lot of steps here, but we're going to be creating a native iOS application from scratch with Scala. So let's get started. So we're going to create React Native Scala app. So we get started, SBT will boot up, and it will load the template. So we're using the React Native library here, which allows you to render native components in apps using React components. So we can do Scala native, Scala.days native app. OK, so we can open this up, Scala.days native app. We can open it up. So if we look at the code, and I'll launch SBT in the meantime, and run npm install to get our dependencies. So if we look at our code, this is what it looks like. You have very similar code. In fact, when Slinky gained support for React Native, it actually required no changes to the core libraries. So that's one of the cool things with Slinky is we were actually able to gain support for React Native using just the external components API. So this is something that you could have implemented in user code if you wanted to use React Native before Slinky had official support for it. So, and then we're going to register a component saying, oh, our native app is app. So our app is just a regular React component. Here now, instead of using HTML elements, you use these native components. So we're going to be displaying an image. You style it. We're going to be displaying some text, and then we're going to do a button. And every time you tap the button, it's going to increment a counter, and we're going to be using that counter to render the count right here. So, OK, everything installed. Now we can compile our code, op.js. And once that finishes, OK, so it is fast optimizing. And we're done. OK, so now we can do npm run iOS. And if all goes well, we should have a native iOS app running in our simulator in a couple 30 seconds, maybe, because it has to build all of the native code required for React Native from source. So it might take a bit. OK, I think this might take a little bit of time. So Let's see. Our simulator is running, so at least that's there. Let's see. Okay. It's doing stuff. I think we can stay here and just watch it scroll by for a little bit. Okay. So doing more compilation. This is only something that has to happen once whenever you're getting started with a React Native app. So all of this native code is all things provided by Facebook. It's the glue between the JavaScript code that's going to be run in kind of a separate process and then what's actually rendering the native components. Because here, this isn't a web view. This isn't using something like Ionic where you're generating HTML elements that are just styled to look like native elements. These are actual regular native elements that are going to be run. Okay, so we have our bundler ready. So this is kind of like Webpack, but it's React Native because Facebook decided they wanted to create their own bundler. So we have that. It is loading the dependencies. So this takes a little bit of time the first time because it has to load all of your node modules and pack them together. But the bundler is incremental, so it's very fast as soon as you get that first run. Okay, what is it doing now? Okay, it's still compiling more stuff. Okay, soon. I think it's almost done. Okay. Okay, I think we'll probably switch back to the slides for a little bit, just talk more about what Slinky lets you do until it's done. Oh, it actually might be done. Yeah, I think it's done. Okay. Yeah, okay, it's installing. Okay. So now our app is there. It's going to be loading our packages. So this is something that also happens the first time, where it's loading all of the modules required. So, and as soon as all of that's done loading, this is not something your user is going to see every time, thankfully. And now we're done. So now we have an application that we just got started with using Scala, plain Scala code running in iOS. It also runs in Android. It also runs on Android TV, Android watches, anywhere you can think of. It even now works on Windows as a native app and on Xboxes, thanks to Microsoft's work on bringing Microsoft devices to React Native. So use Slinky for whatever platform you can dream of. It also supports VR. If you're interested in seeing a demo, I can show after the talk, but for the sake of time, I'm going to skip over that demo. So lastly, getting the full developer experience. Now this is kind of the last kind of cornerstone of Slinky as a framework. The first one is hot reloading. So that's something we saw when we were doing the initial demo with working with Slinky on the web. Hot reloading is actually something that also works with native. So as soon as you change your app, it'll immediately compile. It will get uploaded to your application. And without losing your existing application state, it can update all of your UI. So let's say you have an instance of your Scala.js code. You have your state defined. And let's say you make some modifications. In your new instance of Scala.js code, your properties might actually be under different names. Because of the way the Scala.js optimizer works, your properties can be emitted under different keys than what they were in a previous instance. So if we just try to directly transfer over our state between two instances of Scala.js code, this is not going to work. So what ends up happening is for most Scala.js apps, you just have to reload the page every time you update your code. So Slinky's answer to this is, first, what we can do is take our object in our old instance of Scala.js code, use the writer that we developed for external components, convert it into a regular JavaScript object. So we have text and count. Now this is a regular JavaScript object. There's nothing tied into whatever Scala.js picked for the property names. So this is safe to transfer over into the new instance of Scala.js code. Now the counterpart to a writer is a reader. So we can take a reader and transfer our code back into the new shape that Scala.js expects. And this reader is going to be defined in the new instance of Scala.js code. That's why it knows what the properties need to be. And so by doing this kind of going around with the JavaScript objects, we're able to preserve all this data for application. And every time we update to a new version of Scala code. Now, another thing that's there is Scala.js React is the original React interface to Scala. It was the first one to kind of develop this idea that, hey, maybe we can use React from Scala.js. So if you are already using Scala.js React and you want to introduce Slinky code, there's actually a really easy way to do that with this interop package that's provided by Slinky. So you can take Slinky elements. So for example, this div is being rendered by Slinky, and you can just call .to Scala.js React. And because Slinky emits regular React elements, it can just be treated as kind of an external component from the perspective of Scala.js React. So Scala.js React can just take this in. And you can do a reverse. You can take an element rendered by Scala.js React and convert it back to Slinky. So in conclusion, Slinky lets you use React from Scala.js code with existing Scala libraries. So we using things like SBT for this. You can use any libraries. With the template app, if you try it out, you'll see that we have unit tests written for our React components with Scala test. So you can use anything that you're used to using in Scala code. You can also use JavaScript libraries and tools. So you can use things like React Native. You can use things like Webpack or even the Metro bundler developed by Facebook. And you have a developer experience that's as great as JavaScript. So you have things like hot reloading. You have access to the full developer tools at any time. And so you can be as productive as you would be in JavaScript. But you have all of the static typing now and all of the great features that Scala offers. So you can get started today. So the docs are available at slinky.shadaj.me. If you actually take a look at this website, this shows off some of the more advanced capabilities of Slinky. So the docs are implemented with Slinky as a React application. But when you load it, you'll see that everything's instantly loaded because this uses pre-rendering. So we actually render all of our React components to a static site ahead of time and then use advanced React features like hydration to make our app interactive as soon as it loads. You can check out the source at github.com/shadaj/slinky. So we're always looking for new additions to Slinky, things like more capabilities with React Native or React VR, or improvements to Slinky's API. And then we also have a chat community where we kind of answer each other's questions and discuss new features for Slinky on Gitter. But the easiest way to get started with Slinky is with this template. It gets you started with everything you need, a full build for both local dev and also creating production bundles. So you can get started with SBT new. Now, if you were interested in seeing how Slinky works at a large scale, so my dad is giving another talk today. So the product that he's been developing in his company is actually fully implemented with Slinky. And this is a massive application. It has almost 800 kilobytes of JavaScript, gzipped. So it's a very large application, all implemented with Slinky. So you can see kind of how Slinky scales up to a larger application in this talk later today. And now I can answer any questions. OK, I think there's a microphone. So I guess maybe like a line.
Hi.
Hi.
So regarding the developer debugging experience,
yeah.
In terms of iterating and seeing the hot reload, recompile, Scala, and also just setting breakpoints and stuff like that, can you talk a little bit about that experience?
So breakpoints work. I actually don't have it set up. So with breakpoints, OK, so if we wanted to we can try this. So if we wanted to add a breakpoint, OK, this might be a little harder. Maybe we can try something. Show app source. So if we go to app source, we can see that we have our application defined here. So for example, we could probably grab when we call render, so if I reload my page. So you can see it's paused in the debugger whenever we're trying to render our app. You can actually enable source maps for Scala.js. That lets you debug with your original Scala code. So that makes it a lot easier. And then also things like if you want to debug your app, because that's actually so in this case, we don't have state. But if you had state, you can actually, within the DevTools, modify that state. And Slinky will immediately respond to that. So if you want to try out different data as inputs. Yeah.
And in terms of the recompile time?
Oh, yeah, recompile times. OK, so this varies a lot. It really depends on the size of your application. So for getting started with a smaller app, I see compile times maybe like 2 or 3 seconds because of Scala's incremental compiler. When you're dealing with much larger applications, so in my dad's talk, it can take a little bit longer. But overall, because of the advantages of Scala, I think it's well worth it to wait a couple seconds longer, maybe take a sip of your coffee, and then see all of your code in action without any runtime errors.
All right, thank you a lot.
Yeah. Any other questions?
We switched over to Yarn recently because the front end, we broke it up into runtime loadable modules, etc. Have you had any experience using Yarn instead of NPM?
Yeah, so Scala.js Bundler has full support for Yarn. So I think the setting is just use yarn : true, and you're done. Everything uses Yarn, so everything just works.
Hey, yeah. Are you looking at building any Maven plugins or anything? I know a lot of big orgs, it's tough to sometimes get SBT as your build tool for everything.
So I guess Slinky works in theory with Maven because Slinky itself doesn't require any special kind of build plugins. It uses Macro Paradise, but that already is supported by Maven. It's just a compiler plugin if you're using the @React macro annotation. But other than that, things should work. I guess in terms of bundling applications, you might need something special. It does work. If you don't want to use Scala.js Bundler, you can also just define a Webpack config yourself and do everything. The only thing Scala.js Bundler gives you is the ability to define stuff from your build.sbt and have everything automatically tied together. But everything should work from Maven.
I was just curious about the bundle size that results, because I know we've used, I guess Scala, I can't remember, React Scala.js, the other library.
Yeah.
And one of the problems was that the bundle size was huge because it had to support the conversion. And then the other thing we wanted to do was code splitting.
Okay.
And I was curious about both those things.
Yeah, okay, so the first one, so if we go to slinky.me, this is the doc. So I guess this is kind of a sizable-ish application. So the bundle is, let's see, how do I see how big it is? I think, it cached. Let me disable my cache. So it is 2.2 megabytes without gzipping. So that's not what your browser is going to be loading. It's 684 kilobytes of what you're actually going to be loading. Now it is pretty good. It's actually pretty comparable to what you'll see in production React applications. The thing with Scala.js is you usually get a pretty large initial hit from using Scala.js. So your application bundle will start out large, but it grows pretty slowly after that because you already have all your dependencies in. Now here, if you notice, I reload the page and it's pretty instant. All the content is there immediately. So here I'm actually using pre-rendering. So that's something that makes your application a lot more snappier for your users. So what you can do is have the content immediately there and then make it interactive a couple seconds after that when your bundle actually loads. Yeah. I think we need to wrap up. But for quickly answering bundle splitting, unfortunately, Scala.js does not emit code that is super compatible with bundle splitting at the moment. My dad talks about that a little more. Hopefully, Scala.js will change in the future to produce splittable bundles, but not right now. But yeah, I'll be hanging out in the hallway outside, so I can answer more questions. But thank you.